So I actually, so you sent us a nice abstract, but I actually don't have a sense for what the talk is going to be about. So,
Yeah.
but I'm very excited to hear. So we're lucky to have Benjamin Feuer,
Feuer rhymes with lawyer. Yes.
Feuer, here today to give us his perspective
Yes.
on the recent evolution progress of our field
Yes.
through a data-centric lens.
Indeed. Yes, so to sort of briefly self-introduce, I am mostly going to be, no, entirely going to be talking about LLMs today, but that is not the entirety of what I do. But yes, that's mostly what I'm focusing on today. We will get into me in a minute, but the name of the talk is Annus Mirabilis, charting a year of explosive progress in LLMs through a data-centric lens, which sort of invites the question. And before I dive into it, I'm going to try to keep this talk to 45 minutes. You should feel free to intercede with questions if you have them during the talk, but I am also going to try to leave time for questions afterward if you prefer to hold them till the end. So that's sort of up to you. So Annus Mirabilis is Latin for Year of Miracles. The term was popularized in a historical poem by John Dryden, commemorating the naval victories of the English over the Dutch. I did not know this, I looked it up. And also the Great Fire of London. And why you would commemorate that as a miracle is because it wasn't worse, apparently. A year earlier in 1665, the bubonic plague had broken out in London. So maybe it just seemed miraculous that something that bad didn't happen again. I don't know. And also in 1665, at the age of 23, a young man named Isaac Newton figured out that the moon is held in orbit by Earth's gravity, proved that light is composed of particles, and developed integral and differential calculus in the same year. So that was a pretty good year for Isaac Newton, and sort of led to this term being kind of generalized, in particular in scientific discourse, as opposed to just sort of historical discourse. So LLMs, I would argue, have had a pretty miraculous year. ChatGPT, arguably a miraculous 2 years. ChatGPT is a really impressive achievement in many respects. It's sort of easy to forget because it's so ubiquitous now how fast things have changed and are changing. But we sort of went from stochastic parrots and GPT-3 and like all this sort of kind of noise in the prompting space to things that operate so smoothly in quasi-agentic fashion that we can almost just use them as though we were talking to someone and rarely encounter, unless we're doing something really out of distribution, rarely encounter major surprises. The skeptics have sort of been forced to shift their goalposts again and again. The metaphysically minded skeptics remain completely undeterred. Good for them. But my kind of view of this, as Professor Bao indicated, is primarily data-centric. I'm really interested in some of the open scientific questions around benchmarks. How do we create them? Why and when should we trust them? And what should we trust them to tell us? Like, if a benchmark is kind of this signal in metric form, like what is that signal actually indicating? And with LLMs, I think that's less clear than with almost any other type of kind of metric-based benchmarking because they can do so many different things. LLM judges, which are often used as a kind of component in said benchmarks, like when can we trust them and to what extent should we trust them? And trust's a complicated word, but in this case, I mean trust to be reproducible and predictable, like the things that they do, they will do again, and the things that they don't do, they will not do again. And then finally, synthetic data, which is increasingly supplementing and in some cases replacing traditional kind of human annotated data for training LLMs and also other types of models as well. How can we get the most out of the synthetic data that we are producing? When should we prefer using it? When should we prefer not using it? So these are some of the questions I'm going to be talking about. Now that promised sort of brief about me, I am a third-year Ph.D. student at NYU. My advisor is Chinmay Hegde. My research interests are primarily data-centric, benchmarking, alignment, multimodal machine learning, scalable systems. And a fun fact about me is that before NYU, I wrote and directed movies for a living. So that was my last job.
Anything that we can go and see?
Yes,
That's so cool.
Give us an example.
I'm on IMDb. You can find it there.
Oh, really? Let's look you up right now.
You're welcome to do so.
My boss at Stability was also a movie director.
Really?
I was in the applied team. Yeah. Joe Penna.
Joe Pena.
Penna. Or maybe I'm butchering the name. He has a YouTube presence. And he also did some Netflix movies, I think.
Well, he might have been higher profile than me. I mostly did anonymous rewrites of Disney movies.
Amazing.
Well, you should get into Gen AI.
You know, that's people keep saying that to me, but honestly, I'm enjoying being in an area where I can measure progress more concretely for a change. Anyway,
Fantastic.
so that is my fun fact. Some of my work during my
And
PhD.
some of it was pretty recent. So it says Less Life Love was a 2021 movie that you directed, is that right?
Yeah, that's right.
So it's a pretty recent transition.
It is, yeah.
That's great. Congratulations.
Quite recent.
It's great.
That was basically the year I started, was the year that movie came out.
Nice.
Movies operate on a delay. You know, I shot it in, I think, 2019 and a little bit during the pandemic.
Yeah, it's great.
Yes. Sorry, that movie in particular is whatever. It's an interesting movie. Feel free to watch it if you want to. All right. So yeah, some of my research areas in the master's and the PhD include LLMs, a little bit of computer vision and vision language, AI for science, and tabular data. And very recently, a little bit of work on diffusion models, but I think probably almost everyone in this room knows more about diffusion models than me. So the roadmap for this talk is going to be a 4-part talk. First part is going to be about detecting and mitigating bias in LLM judges. Second part is going to be about mitigating data contamination with dynamic benchmarking. The third part is about how to improve your LLMs by using synthetic data in the post-training pipeline. And then in part 4, just kind of things that I think are interesting and possibly worth looking at in the near future. Although it's always hard to say that because the field moves so quickly that the near future becomes the present a lot more fast than you might think. So LLM alignment, kind of some core definitional challenges here. What do we align to? By what method do we align? This is sort of the algorithmic aspect of the question, is like, what algorithm for alignment do we use? When have we succeeded, right? It's not so obvious, like intuitively, like what an aligned LLM or a more aligned LLM is. And kind of what trade-offs should we expect to be unavoidable? Like we're definitely going to face these trade-offs. So the work that I'm about to talk about focused primarily on the third of these questions, when have we succeeded? But just briefly addressing, just briefly addressing it. So kind of using as a guiding principle, the HHH from Anthropic, which stands for helpful, harmless, and honest. So one way we could conceptualize alignment is we could say, well, if a model is kind of Pareto dominant along all these 3 vectors of performance, and we assume they're kind of linear, they have a direction, and you know, we kind of reach some better state, then we're better aligned. Now, whether that's actually possible to do in the real world or know when you've done it is another question. So how do we actually judge when we've made progress in alignment? So the prominent way to do it, certainly when I wrote the paper, and really still now, even in the age of reasoning models, is using LLM judges and using these benchmarks where LLM judges read the output of other LLMs and kind of render these scores on the outputs. So the names of these benchmarks are things like Alpaca Eval, MT-Bench, and Arena Hard Auto. These benchmarks are generally designed to closely mimic Chatbot Arena. So they kind of operate on the premise of pairwise interactions. And the idea is that there's going to be a winner and there's going to be a loser. And in the aggregate, you develop some sort of metric for general rate of preferredness of model A with respect to model B. So one of the things that we kind of noticed early on when we were kind of trying to do preliminary work in this area, and this was work that I started doing at Arthur.AI, which is a startup in New York. And I was kind of the person who was just very interested in this. And my supervisor was very kind and said, yeah, go ahead and look at it. And just coming from a background of having looked at a lot of standard benchmarks, what immediately struck me is that, oh, there's some kind of new confounds in this pipeline that I didn't really have to think about before. Like this LLM judge, like, you know, doesn't it matter which judge we choose? Like, are they really all just going to behave the same way? And should they even all behave the same way? And how are we converting these judgments into a metric, right? Like, you know, there's not necessarily I mean, you can ask a model to give a number, right? Assign like a Likert score, which is what's done frequently, like a 1 to 5 kind of number of like, how good was this, or how bad was this? How much did you prefer it? Was it strongly preferred or strongly dispreferred? Model A's response compared to model B. But it's not obvious that the numeric scale that LLMs use is actually stable. And if you actually do the experiments, you'll find that usually it isn't, right? Like that some LLM judges will score everything really on the high end, others really on the low end, and they will often have these weird, quirky preferences, or I mean, that's anthropomorphizing. They have weird, quirky artifacts of behavior that are hard to predict in advance. So another thing that I think maybe people don't talk about enough when looking at these benchmarks as kind of measures of progress and alignment is that while overall these benchmarks have very strong correlation with the overall chatbot arena scores, for any particular domain of knowledge that you might be interested in, medicine, law, science, there's a lot of variance because these are small benchmarks. The largest of them is around 500 to 1,000 prompts. So you just don't get a lot of samples available for judgment. So there's this sort of idea that a model can generally become more aligned, but when we actually get down to, oh, but is it more aligned for the thing I care about? You're actually dealing in a very sparse area of knowledge. You don't know that much. Another thing that maybe is not so obvious is that judges must, in order to do their task, make use of explicit biases. This is essentially the instructions they're given when they're asked to judge. So you are a judge. Here are the things you must judge on. You must judge on this, you must judge on this, you must judge on that. If you don't do that, the problem is really not well defined at all. But what's kind of also interesting is that judges may also, and possibly always have to, employ implicit biases while understanding and interpreting what you've written in the prompt as your explicit biases, right? If I say, tell me whether model A is more helpful than model B, inside in the judge's internal architecture, it has to decompose what is helpful. It has to make some sort of meaning of that, break it down into things that we might be able to describe in smaller concepts. And it may not weight all of those smaller concepts equally. That's what I mean by implicit bias. This one's important, this one's not important. So fair enough. Is this something we could study? Here's a hypothesis we could float. Do LLMs implicitly reweight explicit judgment criteria? If I list helpful, harmless, and honest, and I don't tell the LLM like which one is more important, my expected behavior would be that it weights them all equally, but is that actually what it does? And also, do LLMs implicitly reweight infractions of judgment criteria, right? So models can be unhelpful in many ways. Are they all equally bad? What's kind of a measure of severity? How unhelpful was the response, and how do we know? So first, I'm going to speak about the first. So this is kind of a dense scatter plot of
So sorry,
yes.
can I ask you to redefine? So implicit reweighting. So can you expand that for me? What do you mean by implicit reweighting?
Sure. So here I have what is an overall metric for Arena Hard Auto, and it's some score that I've assigned with respect to all models that says like how preferred they are. But then I actually in the prompt I listed 5 criteria: style, completeness, correctness, safety, and conciseness. Right. So I didn't list in the prompt how to weight these 5 criteria. I just said these are the 5 criteria. So my kind of intuition going in was, well, then everything should be 20%. Should be 20% style, 20% completeness, and so on and so forth. So to not see that behavior would be an implicit reweighting of the LLM judgments.
Got it.
Does that answer your question?
Yes, it does. Thanks.
So, okay, so what do we actually see if we do this? So kind of the methodology is in our paper, and I want to kind of move quickly so that we don't get bogged down, but basically across 4 different LLM judges, across 12 or 13 models in the study, across 500 prompts, the correlation between the overall and style rankings was 1. That means there was not a single case in which they differed. We were asked to do like factor analysis and stuff in our rebuttal, and it just like broke the factor analysis. It was literally a perfect correlation. So I had to like introduce a little bit of variance just to get it back. Completeness is almost as strong. It's 0.99. Correctness, considerably weaker, 0.74. Safety, everything's basically bunched up together. This is just like really when it comes to safety, like there was barely any judging going on. And then finally for conciseness, it's actually our 0.025, and in many cases, you're getting the reverse order. So there are a couple things that are interesting about this. First, LLMs do clearly implicitly reweight criteria, but second, they actually do understand the difference, right? Like the model produces a reasonable ranking with respect to conciseness. It knows what it is to be concise, and it knows that conciseness is part of the instruction it was given. It just, when it actually comes time to render the judgment, it ignores that knowledge, even though conciseness is actually a part of style, right? Like to be more concise is in some settings, at least, better style. Yeah.
Do you include these different criteria one at a time?
No. So we prompt everything at once, and then we extract the factor-wise rankings as well as the overall ranking. So basically, the LLM returns 6 scores instead of 1.
Okay. Let's see.
But what if you didn't mention an example of what you gave to the language model to judge, right?
Yeah.
But what if the question did not include any element of safety, for example?
Yeah, this is a good point, right? Like, so, and this is something that that we heard, and I think it's actually a very reasonable thing to think about, is like, well, maybe Arena Hard Auto really doesn't present any safety challenges, so it makes sense that the ranking here is very flat. And I think then my response would be kind of in the sense of meta motivation is like, well, then we don't really have the right benchmarks yet, do we? Because alignment, like safety is a really important factor in alignment. So if we're saying, well, the Arena Hard Auto score went up, therefore it's a better aligned model, then we should know at least that we're ignoring safety when we say that. So implicit rating of infractions. So the idea here is I have a model that initially performed really well. One of the models that was scored very high. And then I kind of break its responses systematically. I introduce like a systematic ablation over every single response. So in the blandness ablation, I have GPT rewrite every response to have simplistic vocabulary, kind of reuse the same words over and over again. I just basically told GPT, be as repetitive as you can. And so that was blandness. And you can see it loses about 8% compared to the base. And that means like if you basically you're losing 8% of whatever that base score was. For wrong, I went into every single, so these were, in Arena Hard Auto, most of the prompts have to do with like a math or a science question. So most of them have like, either the model has to return some code or it has to return some kind of equations or something. So I went through and made sure that there was at least one really glaring error in every single response, which took a while. And that led to a 13% decrease. And then after that, I prompted GPT to make the responses more concise while keeping all the facts the same. Basically, just copy everything necessary to answer the question, but eliminate all the dressing. That went down 63%. And then sarcastic is keep the content exactly the same, keep the facts exactly the same, just have a bad attitude about it. Just like be really sassy and backtalk the user and be kind of obnoxious. And that led to 96% decrease.
So the loss is on Arena Hard?
Yes, Arena Hard Auto as scored by an LLM judge. So basically the conclusions in this part of this work, there are some other stuff that we did in this work that I'm not really talking about here. But this part of this work, LLMs do implicitly reweight their judgment criteria, and they do so systematically. Across 4 judges, across 13 models to be judged, across 500 prompts, same exact behavior, or very close.
Also, if you go back to your previous slide, do you remember which kind of intervention had what kind of effect on which criterias? Like if you make the model's responses more sarcastic, which of the scores go down?
So that's interesting. We didn't actually report that in the paper. The numbers probably are in the artifacts we released with the paper. So I think that's something you could actually look up, but we didn't.
Like I'm trying to understand what was the motivation for doing this intervention experiment?
Basically to understand, so if I have my different criteria, again, the assumption's sort of the same here. Like I'm assuming that because I gave no particular instructions as to how these are to be weighted, they'll be weighted evenly.
Yes.
So 20% weighting for each. That means if I introduce an infraction, if I break a rule, I should expect roughly a proportional decrease, right? So if I take a response that was correct and make it incorrect, it should decrease about the same amount as if I take a response that had good style and now has bad style. Yes. And what this shows is that that doesn't happen at all, right? You go from right to wrong, it gets a little bit lower in the score. But if you go from good style to what the LLM considers bad style, you lose almost the entire score. Yeah.
Is the LLM aware of this implicit weighting? So if you'd ask the LLM, hey, what is alignment to you, and give like a weighting on these 5 categories, would it like be actually reflective of what you find in your intervention experiments?
Great question. We didn't run that experiment. I think it would be an interesting one to do. I guess I will say sort of generally that I don't really trust LLM's ability to kind of self-reflect and report what they're actually going to do. I mean, but you could experiment it. I feel like if it agreed, there'd be a tendency kind of post hoc to say like, we've discovered something. But like, probably if you ran that experiment 100 times, there would be low rate of agreement across different factors.
And maybe you can fine tune for that.
So this is what a lot of concurrent and subsequent work is proposing to do. Yeah. I think it's interesting. I think it's important work. It's not easy because even if you can solve for these particular factors about, as we said before, there are implicit subfactors in those factors that it's turtles all the way down. Yeah. So at some point you reach this kind of level of things you haven't flattened out, and then it gets all wonky again, potentially. But we don't know that will happen. So I think it's worth exploring for sure. It's also worth exploring the idea that you could just get these factor scores and then reweight that, right? Like you once you know kind of the bias, you could just reweight. You could rescore it however you want.
So we have a related work that kind of maybe provides a nice abstraction that could be useful for this, where we check how language models, balance between the information provided in the context and their prior knowledge, which is kind of like the judge instruction versus the biases. I mean, in our toy settings, we are able to create an intervention that lets us, prioritize one thing over the other.
Do you need access to the weights to do the intervention?
Oh yeah.
Because most of the time in practice, you have closed weights models as judges.
Oh, but actually, you can get like a little bit of the performance also via instructing, like listen to the context. Then you get like, I don't know, 60–70% of the performance that you could get with tuning.
That's interesting.
In the toy tasks.
Yes. So, and then we built a benchmark, which is intended to be a supplement for these LLM judges as measuring progress and alignment. It's a fairly large benchmark, kind of a meta benchmark, 19 different test sets, 150,000 samples, and these different tasks are subdivided into tasks that essentially measure honesty, helpfulness, and harmlessness, which we call world knowledge, instruction following, and safety. And in the paper, we report the results on Llama 8B base fine-tunes and Mistral 7B fine-tunes using 20 different curation techniques from the recent literature. And we find that data scaling, rather than the particular curation method, is the best predictor of improved alignment in the SFT stage of post-training, which means basically, to a large extent, I can be agnostic about what clever curation method was used to collect the data. If I collect enough of it, the model gets better regardless, right? So, and this is the challenge, I think, of doing data curation methods research is you often discover things like this. So I think it's good to look every now and then see. But worth noting, this purple bar is the Arena Hard Auto score. So these papers, when they came out, what would they report? They would report, we did well on Empty Bench, we did well on Arena Hard Auto, and so on. That was kind of the standard for publication, is you beat the existing state of the art on those. So you see that that's where you see actually very low correlation with data set size. You can get really, really big delta, and I actually did this mostly unintentionally in a later work, which I'm going to talk about later in this talk, with very few prompts when you're using an LLM judge, because basically the judgment is just not that complicated, what it's considering. Okay. Yeah.
Are you SFT tuning a model here?
These are all SF models that we either trained ourselves, but most of them were already available on Hugging Face. So we just ran them else.
Like data set size K, and on the right side being 1K.
Mm-hmm.
Does this mean 1 million?
Yes.
Mm-hmm.
Yeah. 1 million, 100,000.
These are just SFT data sets containing diverse tasks.
Well, they're SFT data sets which were purportedly curated using specialized curation techniques, like, for example, the Lima paper, which came out a couple of years ago, and now there's a new version of that.
So you're saying they need to be big?
I'm saying that if you look at what actually correlates with improved performance on our benchmark, it's scale.
Okay.
It's not method. Unless you're using LLM judges. Then it's much less clear that scale matters.
Lowest line.
Yeah, the purple. Okay, so moving on, mitigating data contamination with dynamic benchmarking. So there are some limitations aside from, even if we're doing kind of ground truth benchmarks, there are some limitations that we face. Nothing is perfect, right? Like static benchmarks, as they're now called, are fixed in difficulty and somewhat narrow in scope. They tend to just cover one or two topics. I mean, some really big ones like MMLU will purport to cover many, many topics, but there's always kind of somewhere where they end. And the whole thing about LLMs is that there really is nowhere where they end. There's no boundary to what an LLM knows that we are aware of. There surely is one, but we don't know how to map it. But the biggest problem, I think, with static benchmarks is that they get contaminated. And these days they can get contaminated very quickly indeed. So this is a plot that I love for illustrating this from a paper called Data Contamination Through the Lens of Time. It is the marginal pass rate on Codeforce's problems with respect to time. So as you go further back in time, the pass rate goes up. As you go forward in time, it's flat. So I think this is a pretty good way of illustrating the contamination problem, right? Like as time goes up, your P of contamination just mystically drifts higher. And I think that kind of cycle is speeding up as kind of companies, there's more and more of a kind of an emphasis on benchmark beating and sort of just generally kind of trying to hit numbers. So yeah.
Sorry, maybe it's just me, but I didn't really get to know what contamination means in the last slide.
That's a great point. I'm sorry I didn't cover that. So it actually is not an easy question to answer. Like what even is contamination in the case of LLMs? Like the most conventional view that's taken, which I think is woefully inadequate, is that contamination means I literally have a copy of the answer in my training data.
Yeah.
Like oopsie daisy, I copy pasted the answers into the training data at some point. But actually, there's this weird kind of gentle slope from contamination to generalization. And depending on which lab you go into, and when I give this talk in different labs, I get very different views on where that boundary is. But it's sort of hard to say, like if I have GPT rephrase the answer, but keep all the facts correct, right? Like it's still MMLU and all the facts are still the facts, but GPT sort of tosses the words around in its word salad generator. And now it looks different. Is it contaminated if I train on that? Now, I would argue yes, but it wouldn't be caught by the standard methods of decontamination that are used, which is n-gram decontamination. That will not detect that, right? There are stronger methods of detecting decontamination, which were introduced by very reputable authors and then ignored. And you can decide for yourself why that is the case. But that is a multifaceted view of what contamination might be.
Mhm.
Yeah.
So I'm not sure if this is even like what is done, but how would contamination work if you have like a starting sort of question answer, and then for the training data, the starting question is kind of paraphrased a few times, and then all that is used with the same answer on it. But is that something that like labs do in training models? And if so, is that fit into this framework at all?
Interestingly, that is actually a strategy for detecting contamination. So if a model has been contaminated, it is believed, then the exact order in which you pass in kind of the prompt, if you like rephrase the prompt, the kind of log prob of the correct answer should peak. And if you have kind of rephrasings that mean the same thing, it should be down. And if it's sort of roughly the same, then it's thought that the model is less likely to be contaminated.
It's a cool technique.
It is a cool technique. There's some good ones out there now. I wish people would use them.
Give more talks.
Yeah, I'm sure that Anthropic is dying to hear why they should lower their benchmark scores by being really rigorous about decontamination.
Oh no.
Yeah.
So, do you think this is just because people don't care what they're scraping off the internet? And they'll just take anything, even if it's a benchmark, like, or like, is it carefully curated? Like, oh, like we care about this benchmark, let's rephrase it and throw it in the data.
I think both can happen. So Alex Demakis, when he was from University of Austin, when he was recently giving a talk on this topic, said the reason providers won't release any information about what's in their data anymore is that they don't know. And I actually think that that is to a large extent true. They've just collected so much data that there's absolutely no way for them to actually know what's in it. They know what works, right? They know if they like kind of grab this block and, you know, concatenate it with that block and sort of feed it all into an LLM, they get good benchmark numbers out, but they don't really know why. And it's actually very expensive and difficult to figure out why. So I think that they kind of make some efforts to decontaminate, and how hard they try varies by the lab and by the year. But I think everybody's aware that kind of at least conventional n-gram contamination is a problem, and they try to avoid it. But a lot of other kinds of contamination like that I'm talking about here, I think some people would just argue philosophically, like, you should not be concerned about that kind of contamination, right? Like, because if the model is able to generalize to that degree, in practical terms, it's doing what you need it to do, maybe. I think that line of reasoning is shaky, but it's certainly one that people advance. But then there are cases, I don't know if any of you heard about the recent S1 paper. There are cases, so this was S1 is a reasoning model. The idea is that by training on just 1,000 data points, you can convert your standard LLM into an LLM that can reason. And the way that they demonstrate the model is now able to reason is they take challenging benchmarks like AIM 24 and Math 500, and they show that after their fine tuning in GPQA, after their kind of fine tuning on this specially curated data, benchmarks go way up. So if you look in the appendix to that paper, as I did because I am a nerd, you will find that they describe the algorithm they use. And the algorithm they use is they get traces from DeepSeek R1 on every AIM problem they can find that isn't literally n-gram contaminated. And if They know that it gave the correct answer and the trace was correct. They force it to be included in their data set. And as a result, 60% of that data set, that 1,000 samples, is AIM distribution problems. Shockingly, the AIM score is. Because of course, AIM never reuses questions or parts of questions. Anyway, so that's just me editorializing. It's really a very interesting paper, and they released all their artifacts. There's a lot of actually good stuff to dig into. It's just like, but the particular headline result is like.
So the overfit on the benchmark.
Yeah. And if you actually use these models, you discover it pretty quickly, because they're like I've been benchmarking them lately, and like, first of all, like benchmarks that used to be like, if you run when without the reasoning, you will get answers on these benchmarks, which are only like, AIM's only like 30 questions. You get an answer in like maybe 24 hours on one GPU. If you use one of these reasoning models, it will take 5 days because they just generate so many tokens. Anyway, so how do we evaluate LLMs without contamination? This is not such an easy thing to do.
NVIDIA stock dropped after the release of the recent.
Briefly, and then I think it went back up. So we could do kind of vibes-based evals. You know, don't knock them. They're extremely popular. Every single time a new model comes out, you know, you go in and you type in your favorite your private test set of 4 questions that you like
I
to try.
trust those the most.
The vibes evals?
Yep.
Yeah, I think they're
100%.
actually good in many ways. The problem is it's a low sample size, and you can't really generalize across people, right? It's like, because once you make it public, like the sort of Alice in Wonderland trick questions that were used for a while to fool models, and after a while, you know, if it gets popular enough, then they fit on it, and then they beat it. So there's vibes-based, but that has limits. It doesn't scale well. There's private test sets. I think this is a nice idea. The sealed benchmark has a sealed test set that you never see. The problem with the sealed test set is I don't know what's in it, right? Like they can describe it, but if they describe it very much, then they're just risking contamination again. So it's kind of like I don't know what those numbers mean that much. I almost prefer a benchmark that is contaminated, but at least I know what the numbers mean. To a benchmark that I know isn't contaminated, but I also don't know what it means. You can do random humans, randomly prompting, like LLM's Chatbot Arena, but if you actually look at the questions people ask in Chatbot Arena, like you might not be so impressed with the fact that one model beats another on the ELO score, because it takes all kinds to make a world. And so then the final category is something called dynamic benchmark. So the idea behind a dynamic benchmark is instead of having this one set of test prompts that's frozen in time, you update your test prompts over time, like every 3, 6, 9 months, you actually replace some or all of your questions with new questions. Very simple idea. So it's almost like a version update, or like version, yeah.
I just wanted to ask, are LLMs unable to generate novel prompt answers that would like intentionally try and construe something very distinct, or is that just not reliable?
I'm not sure I understand.
Like, because previously, these benchmarks are like, one was created by like random people on the internet, but presumably you could just get like an LLM to generate questions, like generate things to evaluate another LLM on. Is that like, yeah, I was just wondering whether that.
Well, so if you get one LLM to generate the questions, then how can you have confidence that the answers are correct? Unless there's a human in it.
Yeah, I guess maybe you could construct have it in a sort of environment where you can get ground truth, and then it's about how more it phrases it than the actual like novelty per se. But if you have a like maybe like a physics model as an example, where you can probably phrase things in a particular way and then empirically validate using some model, and then if there's some like well-defined way to ensure that like the mapping of how it paraphrases maps directly to the query language, and then you get adequate sampling from that like I guess model, then maybe then you can get some kind of novel answers to things.
Yeah, I mean, I think in some sense that's definitely something people are looking into in domains where ground truth is cheap and straightforward to acquire algorithmically. I think that's a pretty good strategy. And I think it's actually worked really well for things like code. So in some domains that can help.
I guess it's just very narrow, so it's not necessarily, yeah.
Well, no one's figured out the magic sauce yet for how to generalize that to domains where ground truth is more expensive to acquire. There are some ideas, but one such dynamic benchmark that I worked on is called LiveBench. LiveBench is a wide coverage generalist benchmark, really oriented mostly towards frontier models. So the idea behind LiveBench is you have this one score, which can be broken down into kind of subscores on math, coding, reasoning, language instruction following, and data analysis. But taken together, it's supposed to give like a very good kind of rule of thumb estimate for how likely you are to find a model useful and helpful. And all the questions in LiveBench have ground truth answers. Questions are updated over time. Particularly, we will replace problems if they get too easy, or if we detect a lot of contamination on a particular set of problems. And it's all open source, and it has a nice leaderboard, and you can go and check that out. And it's been pretty widely adopted lately by Open.AI and Qwen 2.5 technical report and lots of other folks. So that was nice.
How do you get the question? How do you maintain the live bench?
So it's maintained by a startup called Abacus, and they have an engineer on staff who updates the questions and the topics.
But the questions needs expertise, like there's engineer can change the question.
Well, so basically we rely on the fact that there's a lot of new data hitting the internet on a fairly regular basis, and there's kind of like, you know, there might be a new type of puzzle that comes out where we have a bunch of examples of that puzzle, and we can use it as a substitute for like an old puzzle that became too easy, or we find a way to kind of transform a puzzle to make it a little more challenging for LLMs by adding kind of complexity programmatically.
How many questions is there in the live bench in each session?
I think, yeah, it's 1,000. So it's around, and it's not evenly distributed across kind of areas. So coding, I think, has like 100. All right, and then very briefly talk a little bit about my most recent work, which is on improving LLMs with synthetic data. So historically, going back pretty much any time except very recently, synthetic data generated by models, if you trained on that data, you would get a model that underperformed compared to a model trained on data authored by humans. But there was a very interesting recent work called TabPFN, which showed the transformers trained on synthetic facsimiles of tables generated using MLPs outperform pretty much any model you can pick, deep learning or otherwise, trained on real tables. So that kind of laid the groundwork, at least for those of us who read and loved the TabPFN paper like me, it laid the groundwork for the idea that, oh, we might actually be entering a period where there's a phase shift and synthetic data becomes more useful than real data.
Yeah. Was the argument that like the synthetic tables, there's just like orders of magnitude more of them, or is it like the same amount of data, or?
No, because I mean, there's been models trained at this point. There's like, there's a repository called TabLib, which is like 70 terabytes of tables. I mean, it's ridiculous. Like, I mean, because this is like the world of big data, right? So like there are a lot of tables. And no, even so, TabPFN only trained on, I think, 130 million synthetic tables. It's not that many.
So what was the insight from TabPFN?
There are tons of insight there's a ton of insight from TabPFN. I don't know how much you want me to digress into that, since I didn't write the paper, but it's great. Basically, the way it's framed is as like kind of a Bayesian approach where you sample from a prior distribution over a space of synthetic tables that are designed heuristically to resemble a particular cluster of real tables. And that particular cluster of real tables is a few hundred tables in the OpenML kind of repository. So they kind of studied sort of aspects of normalized OpenML tables and figured out kind of ways to express those more generally. And then they create what they call structured causal models, which are actually just MLPs designed to generate functions. And these functions can be sampled from indefinitely. And if you kind of look at the way these functions appear after you sample them from them for a long time, they look like functions that you would sample from real columns and tables. So at a very high level, that is the idea behind TAP-TFN's data curation. And then the model is just a transformer. It's a relatively small transformer. It's about 26 million parameters.
So they have a data generating process which creates interesting kinds of structure that they think are the kinds of structure that they want.
For tables,
to
yeah, for
transform
table
into
learning,
real
yeah, that's
numbers.
right. And so it's kind of like a space of functions you can sample from that are all kind of normalized to be in roughly the same kind of, because one of the real problems with tables in particular is you get heterogeneity of data, like the scales of the numbers just start to vary widely. And so they kind of normalize everything, crush everything down to this very limited space. And within that very limited space, the model is able to learn to kind of stepwise anticipate what the function is likely to look like at the next time step. So TAP-TFN is not autoregressive, it's set valued, but it looks at all of the input data, which is like called training data, but it doesn't update parameters, it just fits to the functions in the input data. And then one by one, it can predict target values in the output.
I think
Really interesting.
Yeah, it's a very cool paper.
Like I'm always like, what the hell to do with these huge numbers? Like I worked with combinatorial auctions for a bit. So bidder preferences like for items. Yeah, they also like there are rich bidders. They have like multi-million bids, and then there are local bidders like 50,000. So how to deal with that? Just the solution is not dealing with it and normalizing into this range that you train on.
Yeah, it seems to be. Yeah, if you're interested in this, we can talk afterwards. I'm working on actually a follow-up that's trying to define a prior for semantic data rather than numeric, which is all the TAP-TFN does, but that is its own kind of problem. Anyway, so this paper is about synthetic data for LLM fine-tuning. So the paper is called WildChat 50M. We used a bunch of different LLMs and generated 1 million responses per LLM synthetic data generator. The data set we used for prompting was a data set called WildChat, which is just a big collection of questions that people asked of ChatGPT over like a 1-year period. It was sponsored by Oumi.AI. And so these different data generating LLMs, they all answer the questions slightly differently, and in some cases very differently. We actually have some kind of statistical analysis we ran in the paper which show that actually they're not all that different, but yeah, not as different as you might think, but still different. And so then what we do is we fine tune Llama 3 8B base checkpoints on our newly curated data sets. We experimented with blending the different synthetic data generating models, but since we found that they behaved almost exactly as like linear interpolations of the data generating models, it made more sense to just kind of train them singly in the end, which is what we did. And we sort of found that certain data generating models work much better for this task than others. And we're able, based on that insight, to create a relatively small SFT mix that outperformed the recent Tula 3 SFT mix from LLM.AI. So choice of model was very impactful, and happily, I was very unhappy with this insight when I was working on this paper, because I'm like, that's a non-fact. It's true, but not interesting, right? It's like, why does it matter? Like, why are some models better than others for synthetic data generation? This is a very hard question to answer that I worked hard on and made some progress on. So one thing that is definitely not the case, models do not inherit benchmark performance via distillation, especially on hard topics when you're just prompting them with like generic WildChat prompts. And this makes sense, right? Like, the prompts aren't asking for answers to questions in the Math 500 distribution, so the model doesn't learn about the Math 500 distribution. But it's not kind of this naive thing of like, oh, it got better because the DGM was better at that benchmark. It doesn't even work that way for chat benchmarks. Even chat benchmarks, it doesn't actually transfer smoothly, although it transfers more. But they do inherit stylistic, formal and informal stylistic aspects. responses will get longer if the DGM's responses are longer. If the DGM uses particular markdown styles or HTML styles, they'll show up in the model that's fine-tuned. And LLM judges care a lot about style, as we know from previous part of this talk. So LLM judge benchmarks like Alpaca eval and empty bench, which is where we saw the biggest delta over prior work, as opposed to the ground truth benchmarks like mix eval, MMLU Pro, and Muser. LLM judge benchmarks show a huge delta here. The other one that shows a huge delta is instruction following IF eval. This is an area where I wish there was more benchmarks, but right now it's basically just IF eval. So IF eval is this, like they give a wide variety of kind of like very specific instructions to the model about like how many characters it should generate, or like how many, like every third word should start with an L, that kind of stuff. And then they test whether it followed the rules. And so basically, when you use a strong DGM in the upstream, the model learns two important things. Number one, it learns about what it means to actually follow instructions and respond to a prompt. And number two, it learns how to style a response in a way that's pleasing. And that combination of factors means that if you use a strong DGM, you get a strong kind of downstream model, relatively speaking. According to LLM judges, model responses become more accurate, comprehensive, and appropriate after distillation. All right. So what time do we have? Okay, so we're already like kind of pretty far along, so maybe I'll just skip through this and move to questions if people have them.
Oh, future work.
Okay, so we can't talk about it? Okay, I didn't know if we were over time, but it seems like people are kind of more flexible than I here. So, okay, one thing that I'm really interested in, how do we, and actually, Chris, you were just talking about this, how do we ensure the LLMs ground their responses in provided context and fully exploit that context when generating responses? This is kind of like the LLM judging problem. So there was a recent paper from University of Washington called Open Scholar, which is introducing some new methods to try to do this. And there's definitely, I think, progress being made. But long context is a huge challenge here. When you have, the longer the context gets, the worse the model gets at kind of picking the important aspects out. SLMs still struggle compared to LLMs with this kind of thing. And there's generally like a failure to, I think, to ground responses in certain types of context, right? So you can use the term very generally, but like if the context is a table, it's like in a table in a format the LLM isn't familiar with, it might ground really poorly. But then if you translate that same table to like HTML or JSON, it might do much better. We're seeing that in recent experiments right now. Like we're trying to prompt a small Quen model to do better on like table QA. And we found, oh, what do you know? Quen understands JSON, not Markdown, not HTML, just JSON. Okay. Another thing that I think is interesting, what alignment strategies will work best in fields where ground truth is multifaceted and complex? So this was your question, right? Like where we have cheap ground truth, I think kind of the roadmap is actually getting pretty clear at this point. Like there's some really good work coming out of Ludwig Schmidt's lab and others that like, you can eventually just see enough examples with enough reasoning traces that the model learns not just how to answer the right, how to give the answer that works, but how to actually reason its way somewhat to the answer that works. So while I'm skeptical of reasoning writ large, I'm not skeptical of reasoning where we can access infinite ground truth, because eventually I do think it learns the path. But that doesn't work in most domains. Most domains, it's really hard to get those reasoning traces, right? It's really hard to explain, like, for example, rendering a judgment in a matter of law, right? Like supposing I have like this dense body of law, and maybe there's like 5 different statutes, all of which influence how a judge would interpret a particular case, not to mention the fact pattern of that case. And then the judge has to render a ruling. Like we have many people every day in this country who do this kind of reasoning work, and we have no idea how to teach LLMs to do that, right? That's just one example. What doctors do is another. And then this is something that I'm very passionate about. Open source, I'm very passionate about not just open weights models, but models where the data is open. I think it's a real problem that we don't know what data our models are trained on. And we don't, because it's a problem for a number of reasons. But one reason it's a problem is it's entirely possible, and I'm starting to believe it might even be true, that the only way to get the really highly performant models that we all use every day is to train on copyrighted data, for instance. And we don't know yet how it will shake out, whether we're legally permitted to train on copyrighted data. Right now, everybody's assuming the answer will be yes. But what if the answer is no? Then we have to have some kind of data curation strategy to adapt, or we will never be able to train GPT again. That would be a problem, right? So, yeah, how do we reproducibly build fully open source models whose performance rivals that of closed source models? And if we need to do things like train on copyrighted data, we should know that, right? Like, oh, here's the delta we got from that. That should be in the literature. Now, unfortunately, still, there aren't any large, high-quality open source LLMs. Oumi.AI is fighting a good fight here. They did release a 32B checkpoint of Olmo 2 recently. I benchmarked it, and it is a lot weaker than Quen, but it's better than anything that's out there so far. But the gap is still large. So yeah. So those are some talking points. Happy to discuss anything in the scope of this talk or within my limitations as a human outside of the scope of this talk. Yeah.
I was wondering for when you're doing the supervised fine tuning, so you're taking a checkpoint and you're trying to basically teach it a particular maybe like subdomain or set of problems. I was wondering whether when you do that, whether you see how well the model can like answer those questions if it's given in context learning or in context information. So like the supervised fine tuning is training parameters, but maybe it's just learning very simple like subtle changes that like you could learn in context. So yeah, I was curious.
So like, what would be a systematic way, not to put you on the spot here, but like, what would be a systematic way we could ablate something like that, right? Like, different models would understand different forms of in-context prompting better. There would be a tendency, I think, to optimize, to prompt engineer around the constraints of a particular model. Oh, what do you know? For this model, chain of thought works. Why? Because it was trained a lot of chain of thought. Oh, for this model, it's more like it likes few shot. Maybe it likes to be told. My grandmother is in the hospital and she desperately needs you to, to do this, to answer this math problem for her. So I don't know. That's kind of a non-answer, but like, it's maybe like pointing at why I think they are fundamentally different domains. Like one is sort of exploring the space of a model that is already frozen with all its quirks intact and kind of saying like, where do the quirks lead us? And yeah, I would even throw methods like DISP and TextGrad, which claim to be optimization into this bucket as well, where they're basically, they're just sort of learning the noise on the surface of what the model happened to fit to. The reason I prefer things like SFT is because I understand well what that process does, and I understand what it does for models that aren't LLMs, so I can expect similar effects when I do it with LLMs where it's harder to benchmark.
If I were to like naively think about it, I would think that since comparing with like you're kind of wanting a specific specialized model, and it sort of doesn't matter what the context for the supervised fine tuning is, as long as it does well in this kind of subtopic. So you could almost like just take the best resulting supervised fine tuning, like just sample different ones. And then if it turns out that that is still doing better, it's doing better than the fine tuning, then you have a prompt that does well in that sort of range. It's a bit naive as an approach, but I guess that's kind of my intention.
Yeah, I mean, I think, it's certainly an area one could look at. I will say, if you're referring in particular to this work, that the point was actually not to SFT to a particular domain, but to SFT more general. Like the idea being generally, let's see if we can make a model that's better at a lot of things. As it turned out, we couldn't necessarily make a model that was better at a lot of things, but we could make a model that was better at things that had to do with instruction following and conversation. Generally, it would appear. Yeah.
Going back to your first topic, so you're talking about like looking at implicit biases of LLM as a judge.
Yeah.
And I think now with the reasoning models, I've seen some people using the reasoning models as a judge as well. And do you think if there's any value in looking into the reasoning chain and then see like whether like the LLM will verbalize its bias or like in how it arrives at the decision?
So the short answer is yes. The slightly longer answer is LLM judges already do that. They already give reasoning behind their decisions and their judgments, but that reasoning could conceivably be different than the reasoning that would be generated as part of an internal chain of thought. The idea being that what a model might say to itself in private would be different than what it would say in public when kind of explaining its decision. That's actually a distinction that a real judge would also employ. So like, it's not unreasonable to think like models might reason better if they have an idea that some of their reasoning is private. But that said, I think we're like, so right now I'm working for a company called Oumi. I'm interning for a company called Oumi, and one of the projects that I'm supervising is basically that. It's looking at this same problem, but with reasoning models as judges and kind of asking, can we fine tune these reasoning models to make them more reliable judges by like improving the internal thought architecture.
And just follow up, did you see any difference between the reasoning chain reasons and if you ask an LM to give you post hoc reasons for its decision?
We don't have the results yet, so I don't know what we'll see. I would certainly hope they'd be different. Whether we can quantify the differences in a way that I will find satisfying, I will have to do some thinking about that. It took kind of a lot of thought to come up with this experiment. Like there were a lot of experiments that I thought of that I didn't really like very much. Like it's sort of hard to say like, oh, this was better reasoning, you know, when it comes to like rendering a judgment. It's like better according to what? You know, like what, you know, what's your gold standard for reasoning? Internally consistent? You know, are you going to try to do some sort of like hallucination detection? Because then the longer ones will always look worse, you know, etc.
What's like your go-to benchmark or a couple benchmarks that you use to like check stuff out for a new model?
Well, I'm biased, but LiveBench. LiveBench, I think, is a really good benchmark for what it is, which is like kind of should I pay attention to this frontier model or not? I think LiveBench is great for that.
Because it's designed not to be able to be overfit too. Is that why? It's because just because when you look at a benchmark, your first reaction is, oh, that's very easy to game.
Yeah.
Yeah.
Even Chatbot Arena, which like many people present as ungameable, like if you actually go and look again, like there aren't really infinite questions in Chatbot Arena. It's really that people ask a lot of the same questions over and over again, and more importantly, people themselves are hackable. Like that's another part of this paper that like people's judgments are hackable.
Sure.
We didn't talk about it as much because it's more like social sciences than something I would publish in iClear, but like it is true, right? Like there's tons of literature on it. So when you train an LLM judge to behave like human judges, you inherit their implicit biases as well. Anyway, so to answer your question, I like LiveBench. I also like Mix-Eval if you want like kind of a cheap to compute thing that looks kind of behaves like an LLM judge but is based in ground truth. I think Mix-Eval is very nice and it's small. I love SweBench. I think SweBench is fantastic, and I think there should be more like it. The only downside of SweBench is it's really hard to run because you basically need like a Docker container and like a special environment, because it's basically, for those of you who don't know, SweBench is a benchmark where you start with a prompt and you end up with a pull request. So the model has to do this kind of agentless reasoning going all the way from the prompt, like figuring out which tools it needs to call, to writing the code, to actually diffing the code, to submitting the diff. And either the diff's accepted or it's not. You run certain tests on the diff to see if it passed. And it's based in like real repos, like scikit-learn and stuff, and like real kind of feature requests and bug fixes. So I think that kind of direction of like these sort of focused practical benchmarks, something I'm excited about. I also love it anytime someone actually does the work to come out with like a new hard math benchmark, because it's so hard to make them. I feel bad that they like get contaminated so quickly, but like there was Putnam Axiom recently came out, and right now it's pretty good. I'm sure in 6 months they'll have mysteriously, the numbers will float up. Humanities last exam, same story. So I guess the rest are kind of like domain specific, but like for general, I like those.
I have a very naive question. Do you think it's feasible? So when a company or an org trains a model, that they watermark the inputs and outputs to everything, so that later on after it's trained, you can see whether it produces the output from the seed input, and it would be like kind of algorithmic, because maybe the watermark is like with respect to like a pair, and so for each pair you could like you'd be able to query the query for it using the key, some database, and then your answer would abide to the watermark in some respect. Yeah, I don't know. It's a bit of a out there question, but given you thought about this stuff.
Far from being an out there question, I think LLM watermarking is a really active subfield of research with lots and lots of papers. DeepMind had one. I think so. My initial kind of hot take, which I'm prone to make hot takes that are way too premature. So my premature hot take on LLM watermarking is this is impossible. Nobody should be trying to do this. But like I think upon like reflection, I would have to say it's just very hard to do it generally for everything. But like if you have enough text from a model, it's not at all unreasonable to imagine that you should be able to identify, like the more text I get from a model, at some point I should have enough that I know if it's model A or model B, as long as it hasn't been contaminated or messed up, right? Like if some human gets to go in and adversarially change words, especially if that human has access to the algorithm that was used for watermarking, then I'm skeptical about it all the time. So I don't think it's like a good defense against, say, like people who want to cheat on their exams with LLMs because of what I just said. But if like if you're using it more sort of like internally, yeah, it should be possible. And I think it is possible.
For the diffusion models, you have this hidden in the noise paper, right?
Yes.
There you're like, okay, I can just make a database of my
database of
noises.
noise. Yes, a database of noises, as Niv calls it. You of course know Niv.
Yeah, Niv hosted me last year.
Yeah. I was sorry I couldn't make your talk. So yeah.
It was fun.
Yeah, no, it was my first foray into diffusion models, and I think they're great. I really enjoyed Rohit's talk when he came to NYU recently, so would love to learn more about diffusion.
So I have a
By the way, did you take NeurIPS Spot?
What?
Did you take NeurIPS presenter spot, or was like because like NIF wanted to come here as well?
Oh, he was here.
He came.
He was here
like,
a
a month
few weeks
or
ago.
two
You missed him because you started a little too late.
Oh no, but like he wanted to come here again.
Oh, again?
Yeah.
Oh, well, we haven't. He hasn't gotten in touch with me to schedule another one.
I put him in touch with Kuyana.
Oh, okay. Yeah, we'd be delighted to have him.
Okay.
Yeah.
I did not know he was planning to come again. I knew he had come.
We were
Yeah.
chatting about it.
Yeah,
Maybe
it's
it's unofficial.
I
Sorry.
don't think I took his spot. I don't know.
If you don't know about it, you didn't.
Okay.
So I have a naive question about benchmarking, and then I have another. So the naive question is, isn't the standard thing to do to have, the secret, to split your benchmark? You have a public part and you have a secret part, so the secret part can't be gamed. Is that not a good defense, or do people, or when people game the public part, do you feel like that sort of contaminates the secret part that you held back?
So if I have enough meta information about the benchmark, then I don't really need to see the samples to contaminate, right? Like I can guess. That's sort of in a way, that's like the S1 problem, right? Like, okay, they're holding out the 2024 edition of 30 questions from AIM, but they're training on 1980 through 2023, every single question that was in AIM. The P of exact overlap is high, and it gets higher the more you can sample from the distribution. So like at some point in expectation, you will just sample every single AIM distribution question there could be, close enough that an LLM can fuzz it, right? Like, and there you face kind of the question of like, well, is that really contamination? Is that just the models learning to generalize?
Yeah.
And I don't know the answer to that, right? Like that's philosophical on some level. I think that it's more that it's contamination when you can't make reasonable transformations and reasonable changes and still have the so-called reasoning hold up. You know, like if I'm able to like just make the prompt longer and all of a sudden it can't reason, then I question whether it was really reasoning.
So let me ask a flip side question. So, you know, if we as a field succeed in this reasoning dream and get models that can be creative, that can come up with generation of insights and knowledge that humans have never had before. What's your perspective on how we should recognize that or benchmark that?
So creative, meaning they can do things that are
like the way that we can do in board games today, where you know, oh, we have chess players that can employ chess strategies that grandmasters cannot come up with, or you know, or that kind of thing. Yeah.
Yeah. So I might say like, so right. I mean, so there's like the Go models and the chess models that can figure out kind of move sequences in a fixed system, like in a narrow system that are novel, that are undiscovered, or like the protein discoveries, right? Like
Right. So in broader domain, the general purpose domain, in the LM domain, general knowledge, you know, is it feasible? Like, what would we do to recognize when we're succeeding in doing that? Or is there a way of benchmarking that?
so as a former filmmaker, I would argue that there is a difference between creativity in hard problems and creativity in wicked problems. Like that basically protein folding or chess is a hard problem. It's just like there's a lot of combinatorial possibilities, but they're finite and there are rules, and the rules pretty much always hold because they're kind of governed by systems. I think creativity in domains like that, we already know is within the reach of frontier models, and they do it very well. Compositional creativity, right? Like sample a little from here, sample a little from there, smush it together, voila. But like David Lynch, who recently passed away, is someone I consider to be a supremely creative individual. And he was creative in like a field that I consider to be a fairly wicked domain, film, where like you sort of have 90 minutes in a blank slate. Anything you can imagine in images, anything you can imagine in sounds, you're allowed to do. There are no rules. There are no, and every time someone tries to make them, the really creative thing to do is go and break the rules and show that you can still make it work. And I don't, not only do I not know how to benchmark that, I don't even know that I believe that any sort of algorithm that's based on the convergence of probabilities towards like kind of local maxima could ever do that. Because like what David Lynch does is like, well, because everyone's going here, I'm going to go over there. Not to be different, not to be contrarian, but just like because I see things differently. And then you get Eraserhead, which is like unlike anything before or after, to me.
So you're skeptical that the research program could ever succeed in doing this?
I think we spoke about this a little bit, actually. It's like, here's the thing. I think in order to do it, we would first need to figure out how to measure that we've done it. And I don't know. It's hard for me to conceive like how you would measure that you've done it. Like, diffusion models, being creative, diffusion models coming up with genuinely new stuff that's not like kind of again like interpolation of artist styles. Like, what would that look like? You know, like how would you know when you'd seen it? Like sometimes if you kind of I see presentations on diffusion models and they kind of scan the latent space and they discover something that they can't interpret. And I say, I can't interpret that. I can't put that in my paper. That's not anything. But like if I was Matisse, I might look at that and say, that's my canvas. Now I'm going to start here because this expresses what's in my soul. And now I'm going to build on this and then I'm going to make it my style. So like, if you like, what do? You put a label on everything? Like, you can't put a label on something until it's a thing. That's not a thing until somebody kind of shows you that it's a thing.
Already had some cool results about this.
Yeah.
Just the slider space.
Yeah.
The principal components are at least not overlapping really with artists, but which is not the proof, of course. I think, but it's kind of interesting.
Yeah.
What do you think about this? Let's make a game show. Robots versus humans.
Yeah.
Yeah. Generally intelligent robots that do something like drawing a painting, making a movie, versus generally intelligent humans. And we just see who wins.
If you're measuring by human preference, the robots will win eventually.
You think so?
Yes.
Because humans are hackable, as you were saying.
Yes, because humans are hackable. Humans don't know what they don't know until someone like David Lynch or Henri Matisse comes along and shows them. And then they're like, now I know that. And then it becomes part of the cultural conversation. And then people copy it, and then it becomes a cliche, and then everybody forgets it, and then the cycle starts again. But like,
if they can recognize the novel contribution as that seems like that's a solution to me. If you have people who are able to say like, oh, that's good, that's good.
Well, the people who are able to say it are mostly deplatformed and absent from the cultural conversation at this point because we've devalued criticism and we've devalued kind of the idea that there could be such a thing as a judge of art. There used to be people whose profession it was to go and watch all the art, and there still exists in some places in diminished capacities, but there used to be their job, right, to go in and watch everything, and then they would know what something new was. But then we sort of all decided, we're better judges than they are. We don't need these guys, bunch of snobs, right? It's like, okay, but then now it's new to you. It's not new. Right, like, and somebody who knows would tell you it's not new, and then you say, "Shut up, you snob! I like it." Yeah.
How would you classify the AI photo that won I forget which competition it was. Yeah, if that passes, does that mean creativity?
No, I mean, no. It's like, here's okay. I don't know how again, like, I would love to design a true benchmark of creativity. It's like such a cool idea, but like, here's how hard I think the problem is. It's like, I don't know what it was like for you or if people in the room have had this experience, but when I was 18 years old and I watched Twin Peaks for the first time, it was like my brain just like lit up and went to another area. It's like, now I know what I want to do. And like, I didn't even know this world existed. It was like, it haunted me. It was like, I was thinking in different ways. I was seeing in different ways. Like, it literally transformed my perception. And there are, like a dozen or so filmmakers throughout my career who did that for me at different times. And it's not just me, right? Like, I'm not the first person to think David Lynch is special. Lots of people have this experience watching David Lynch or Ingmar Bergman or Jean Renoir. So it's not like it's just some idiosyncratic quirk of me. It's a transformative experience that others can access, but not everyone. And some people hate Lynch and hate Godard and hate Renoir. And they hate the feeling of being pushed out of their comfort zone by the media because they don't want to go to that place. And so they say, like, give me something comfortable. Give me my comfort food. Give me my Star Wars. It's like, okay, you can have that. It'll tell you what you already know in the way you're already comfortable hearing it. But the discomfort, that initial discomfort, is part of the transformation. So it's like something that's received, I think, by it's like something that happens to the receiver more than it happens to the artist. And I don't know how you model.
I love it. I feel like it belongs on your future work slide.
Yeah.
That
was really
all right. I'll think about it.
I
like-
agree.
I don't know. Maybe there's some way to do it. Maybe it's like, maybe there's some way to do it.
Do you see a
Yeah. Go ahead.
me?
Yeah. Well,
Do you see a relation between novelty and creativity? Is that a proxy? I'm sorry,
necessary,
sorry.
but not sufficient.
So can it be a proxy for evaluating creativity?
Evaluate novelty.
Novelty?
Evaluate novelty.
Yeah, if you had a good enough judge, you could do it. Like that's basically the role of a critic. The role of an art critic is to say this is actually new
And good.
and good.
And
But almost sometimes just new is enough. Like sometimes the art critic will say this is not good, but it's new. And like that also can be valuable. It's like this almost worked, but it was actually terrible. But you should consider watching it. Like people like me, like we would go and seek out those movies that were like bad but interesting. Because that's where you find the seeds to make something good and interesting. The noble failures, the Adventures of Buckaroo Banzai.
Yeah.
You know, you've seen that movie?
Yeah.
Oh my God, what a mess. Sorry, what was your question?
yeah. So measuring novelty might be a
More tractable.
simpler, tractable question because you have access to the training data.
Yeah, so you can measure surprise, right? Like,
Right.
in some entropic sense. Then I think the question becomes like narrowing the corpus selectively in a way that prioritizes certain subdomains, right? Because if your domain is all images, then what's surprising is garbage because it's not like images.
Yeah.
There's a huge space of noise and images live on this tiny low dimensional manifold surrounded by lots of noise. So like the hard thing is finding useful directions for noise that exist in like almost vectors of meaning. Like there are certain vector directions that lead to meaning, but most lead to noise, which is why most experiments fail in art.
Right.
So in an abstract sense, what would you say is the gap between novelty and creativity? What's that missing direction?
Here's a mushy answer for you. Intuition, like, and taste, like the ability to, so as I just said, like monkeys on keyboards, right? Like there are literally so many vector directions you can take from a starting point. Pick a starting point somewhere in the world of things you can see. Pick a direction. You move in that direction, you'll get somewhere. Now pick another direction. You move in that direction, you'll get somewhere. Is there a causal link between these two directions you picked? Intuition will tell you whether there is or there's not. Right? Like we all have some degree of intuition, right? If one direction leads you to a cow, and then right after the cow, you get an image of milk. And your intuition will tell you, these are linked. You don't know where that intuition comes from. It's not easy to bound that intuition. Because I could also follow cow with factory, and you get a different association. It's called the Kuleshov effect in film, where the edit creates the meaning. And so you could juxtapose sequences of images and create meaning in the mind of the audience that's not actually in the images. Mm-hmm. It's in the latent space of the audience's mind. And that is what artists exploit. They exploit at least film artists, they exploit what the audience knows and what the audience expects. Yeah.
Don't they also exploit like the emotions that the audience might feel? So like intuition does come from knowledge, but I feel like it also comes from emotions. So that's probably also what's lacking.
Oh yeah. But emotions are like partly triggered by our expectations. Like if you go into a scenario expecting, say, a horror movie, and then you find out that like all the vampires are goofy, then you might be in What We Do in the Shadows. And you might be surprised to be in What We Do in the Shadows, and then you might like that. And a lot of people do like that, right? Which is where you get something that many people call creative. It's like vampires, but like hipster vampires, and it's funny instead of being horrifying. So that's a form of kind of low grade, but meaningful creativity. It's not just a random juxtaposition. It's not like some interpolated vector between like vampires and comedy, because you had to pick poles that were going to be meaningful in the mind of the audience. And then when you met in the middle, it created something.
Another wonky question. Do you think that if an AI model is capable of causing a human to fall in love with them, that it then would have the capability to produce an artifact that would be judged creative by that human?
No, because humans can anthropomorphize anything. Humans can anthropomorphize their carpets. You know, like it doesn't mean anything, right? Like it's the human that's special, not the AI. Humans can make meaning out of anything. It's kind of what we do. Like it's really important that we can do that because it's how we relate to one another. But we can do it for anything. We can do it for our toasters if we really want to.
You're saying the content.
Like Tom Hanks in the beach ball and Castaway.
Yeah.
Right, Wilson. You know, if you're desperate enough, you can anthropomorphize a beach ball or volleyball.
So that was
Volleyball. My bad. It's factual error.
like for humans, we also don't know where this comes from, right? So there are some people that are making the point that we are kind of a product of evolutionary process, which is kind of like a weak optimizer.
Yeah.
Like just random mutations and some stuff sticks.
And where stuff's highly conserved, right? Like
Right.
there's all this
Yeah,
stuff
yeah.
that's conserved in evolution that's
Right.
kind of bizarre.
So some people then start drawing the analogy in how we actually optimize with a better optimizer. Like we are using gradients to fit something to some huge data pile or whatever. Yeah. So and then they are making this point like evolution gave rise to humans, right? So this other optimization procedure could also give rise to something interesting, something maybe even superhuman. I mean, I really love your sober take. Really love it. But do you have something to say to that?
About the impossibility of creativity.
No, he said something superhuman. I'd say Claude is already superhuman.
Well, but also along the creativity axis.
I just don't see it. I'm very skeptical. I would love to be proved wrong, and I'm happy to sit and muddle over a research project but again, I would think first in terms of benchmarks. Like, how would you ever know that you succeeded?
Right.
Like, that's the first place I would start is show me a measure that quantifies how close you've come from on the scale of a platypus to David Lynch. And I would be very impressed that you had come up with such a measure because, as far as I can tell, even simple scores of image fidelity are largely noise. We don't even have a good score for that. This is a better or worse image. We can't even score that. How are we going to score this is a more creative image? As a prior, we need to know at least what's better. And we need to be multifaceted in the way that the LLM judgments are. This is better because it's scary. This is better because it's more impactful. This is better because it shows more craft. If we could say those things, we control those things, then we might be able to steer the evolution of a learner to force it to take a non-majority path through the data. Might be able to say, I'm going to force you to ignore the fact that there are lots of bright images because you are going to be a chiaroscuro artist. So you are going to be attracted to dark images with lots of soft shadows and lots of soft color. And it's not because I'm going to throw away the other data. You're still going to know it's there, right? But you're going to prefer this data. You're going to be biased. You're biased learner.
Would you make a bet about whether basically, would you make the bet that no AI generated movie will ever win an Oscar?
No.
Because an Oscar might be hackable. So
Oscars are super hackable.
So actually, I kind of here's a data setting for you, and maybe you need to build a relationship with one of these startups that you work with. But I feel like, okay, yeah, if humans are hackable, and yet there are expert humans who might be experts in creativity. So if you had access to the OpenAI logs, or for image generation, if you you joined the staff of, what's the big image generation company?
Leonardo is pretty
What do
cool
you say?
now. Leonardo AI.
Leonardo or whoever, has
Black
done-
Forest Labs.
Black Forest Labs, right? So.
Stability got dissolved.
And,
Oh, it's gone?
I
and
mean,
you
no,
just,
it's not
and you just
gone,
got
but-
all those usage logs. Most of the users are doing not very interesting things. They're not very discerning. But with the right analysis, you might be able to identify, there's some real experts in here who really understand, what they're doing, who are really steering these things in creative ways, or recognizing the difference between what's creative and what's not. Maybe it's about identifying those humans, and that could be a source of an interesting sort of benchmark or a test or something like that.
So if I imagine that each David Lynch
Yeah,
is some low probability path through the distribution of all data
yeah.
that lands at some endpoint, which is totally not random and totally not the most likely outcome.
But somehow
But
great for some reason.
yeah, and
Yes.
somehow great for some reason.
Yes.
Well, a bunch of other people landed somewhere else. We don't know who they are, right?
Yeah, yeah.
But I know that trajectory, fine, but that's O of one. I only have that one. I don't know what's near it. And I don't know really how what's near it is different. I don't know why, if I go and copy everything David Lynch did, and I could, the movie would not be as good as a David Lynch movie, right? Because people try to do this all the time in
Yes.
Hollywood, right? They try to copy something successful, and it sucks. Because you can't copy something successful. It doesn't work that way. Because you're missing something about
and also because it's the second one now.
that too, right? So then okay, but in order to learn in machine learning, we need lots of data,
Sure.
lots and lots of data in the near region of the thing we want to learn.
Right.
But what's in the near region of the creativity of David Lynch and the creativity of Ingmar Bergman and the creativity of
So I'm not proposing a
Yeah.
way of solving it. I'm just sort of proposing, there might be a path to benchmarking, right? Which may be the first. Your prerequisite. You're like, I
Yeah,
don't
no,
think it
that's
can be
true.
right. Does that make sense?
So the
Yeah.
idea being that there might be, that's true. There might be learnable, there might be learnable commonalities in the trajectories, even.
Or even in the sense of your live bench, maybe it's not even a benchmark that's automated. It could be a benchmark made up of systematically identified humans, right? We have this 0.1% of OpenAI users who we judge are the best, judges of creativity. So if you really want to benchmark your creativity algorithm, then, pay OpenAI a little fee, and we'll mix in your algorithm into a little bit of their outputs, right? And if they seem to prefer it, these people are seeking out creativity. You're doing a good job. Kind of inspired by your live bench, but maybe a scalable way of doing it.
Yeah, there's certainly something to the idea. But there's latent commonalities that aren't obvious. But you actually have historical data, right? You actually have lots of historical data on which artists became successful and the context in which they became successful.
Right.
Which ones did not. Now it's often you could assume some of that's noise, some of that's randomness, but is there something learnable?
It's interesting. Benjamin, what a fascinating conversation. Thank you very much. Thanks again for coming.
My pleasure.